Hello everyone, Mr. Fugay here, and in this video we're going to talk about what DeltaMath is calling level 2 word problems, or as I'm going to call it here, multiple triangles in a given situation word problems. So in these problems, the pictures will be given, so it's a matter of just interpreting everything and being able to find what we need in a problem. So what we have is a boat heading towards a lighthouse, and they've given us the height of the lighthouse already. So that's been labeled in my diagram. And what's happening here is the crewmen in the boat are measuring the angle of elevation to the top of the lighthouse at two given moments. So the first one they note here is an angle of elevation of 11. So that's going to be from the first point on the boat here. So we would write an 11 right there. And then as they draw closer, they measure it a second time, which will be 24 degrees. And what we need to do is we need to find the distance that the boat has indeed traveled. So what we're looking at here are actually two right triangles. We have a right triangle formed by the lighthouse and the 11-degree angle, and then another one formed by the lighthouse and the 24 degrees. So let's draw those out separately. So we have the much bigger triangle here, and that's going to be 11 degrees here. We don't know that side, so let's just call it X. And then this opposite side is going to be 15. So we have the trig tools to be able to find that missing part. But then we have the inner triangle right here as well, if I trace it out like that. And so when I draw that triangle in, we have this 24. This is also still 115, and the adjacent side, let's just call it Y, okay? So what I'm going to do is solve both of these problems and then interpret what these numbers mean in my problem. So I'm going to write this out as tangent of 11 equals 115 over x. And so I'll multiply both sides by x. We get x times tangent of 11. Now I know I can put that in my calculator at any point to write the decimal, but I'm going to wait until my final step to do this now, trying to save myself just writing a bunch of decimals in a problem. We're going to divide both sides by tangent of 11, remembering that that's just a number. It's some decimal. And so in my calculator now, I'm going to go ahead and type in one operation, 115 divided by tangent 11, and we will get an answer of about 591 point. I'm going to go to, they said round to the nearest foot. Let's just go ahead and round to the nearest hundredth for right now. So I got 0.62. All right, again, we'll come back and we'll interpret what that means in just a minute. Now we're going to take this triangle and we're going to do exactly the same thing, quite frankly. It's going to be tangent of 24 this time, and that's going to be equal to 115 over y. We'll multiply both sides by the denominator, so we'll have y times tangent 24 equals 115. Divide both sides by that tangent of 24. And once again, I'm going to go into my calculator in one operation and do 115 divided by tangent of 24. So I get an answer of 258. We'll go nearest hundredth again. So this is going to be 0.29. Now, let's interpret what we've actually solved here. The 591 is a representation of the entire length from point A all the way to point L. So this would be 591.62 all the way across from the first measurement of the boat to the lighthouse. And then the 258 is actually the measurement from point B to point L, the lighthouse. That's going to be 258.29. So if we're now looking at the information provided, what we actually want is this measurement right here. And so hopefully we can see via the segment addition postulate, part plus part equals whole, that I can just take the 591, subtract the 258 from it. And when I do that, let's put that in my calculator, I'm going to get an answer of 333.3. So this missing measurement is 333. Since we'll round it to the nearest foot, I'll just go ahead and now round it and say that the distance the boat has traveled is 333 feet. Now, this isn't the only variation of this problem you're going to get presented with, because from this perspective, we were looking from the boat, looking up to the lighthouse. But what if we were in the lighthouse? Could we do the same thing? And so let's look at one final question here in this video. In this situation now, we have Kaylee watching from the top of the lighthouse. And so you'll notice the triangles look a little bit different in this problem. But what we're going to see here is that the angle of depression, which is now measured from a height, is going to also create a very similar mathematical process. So the first measurement, so we have the 118 feet, we'll start with there. We measure the angle of depression to the boat at point A to be 7. Now I'm going to go ahead and trace this triangle out in pink just to help trace out what's happening here. And then we have this one, Okay, so we have that larger triangle. And so right away, let's just kind of note what's happening here, that we have this 7-degree angle. Now, even though it may not directly be given, we actually know this height here on the left-hand side. This height is the same as the height of the lighthouse, so we can say that's 118. Likewise, we can also say that this entire length across the top is actually the distance from the lighthouse to the boat on the actual water. So we'll write that there. Now, the second angle of depression that was measured to the boat at the closer location, and that was measured out to be 51. So that's this entire angle here. And if I were to trace out this triangle here in blue, we'll see we get a much smaller triangle, which would look like, that is a bad line. Let's try that again. Okay, so that would be 51 here. The height is still 118. We do not know this length y, and you will notice it's almost the exact same process as the last problem. It's just from a different perspective. So take a moment if you'd like to pause this video, go ahead and set up and solve for both the pink and blue triangles, and actually see if you can then interpret to get the final answer, and I will review it with you in just a few seconds. So pause the video before all gets revealed. All right, here is the solve for each of these. So again, very similar process using a tangent ratio, multiplying by the denominator and then dividing by the tangent of 7 to get all of our final answers. I went ahead then and transferred those answers back up so that we can interpret what we actually need to do. Like the last problem I showed you, we need to figure out this length right here. So all I'm going to do is subtract those two answers from each other. And when I do that, I get an answer of 865.48. I believe it's asking nearest foot again. So let's go ahead and just say 865 feet as our final answer. So notice here with these multiple triangle diagrams, draw them out separately if you need to, do the mathematics to solve it, but then most importantly, bring the numbers back into the problem and interpret what you'll need to do. That will conclude this video. You can go ahead and try those level 2 DeltaMath problems now. Have a great day.